All right, and now for that last video, I want to go back to where we were. We found out what the confidence interval was, the 95% confidence interval. It says in part B, and I forgot to do this part, so we'll do it now. Interpret the interval in words. So the interpretation of this interval is we are 95% confident that the true proportion of the population of seniors who favor a ban on prayer in public schools is in the interval 0.08003, comma 0.21997. So that's your interpretation. All right, and that's how we're going to have to start to get used to writing these questions up. All right, next question in the packet, and you can take notes on this. But the next question in the packet, going back a page, is we're dealing with a sample mean now. Okay, and when we're dealing with a sample mean, now again, assumptions, which we're replacing that word with conditions. Okay, so the conditions for sample mean is 1, SRS. Population is normal. That means it's stated in the question the population is normal. If it's not stated in the question, that then we have to know that n is large, and the test for largeness is it has to be greater than or equal to 30. As long as n is greater than or equal to 30, we can state then it's normal. So either the question says it, or your sample size is greater than or equal to 30. And number 3, if the standard deviation is known, all right, we're going to be using a z-star value. It's a z-star value if it's known from the population, and we're going to use this formula to calculate the standard deviation, all right, which is the formula we've always used for sample mean. And you can see, here's our estimate, plus or minus our z-star score, and then our standard deviation for that estimate. Okay, so here we go. Our question that's being asked. The gas mileage of a certain model car is known to have a standard deviation of 5 miles per gallon. So this is the standard deviation from the population. A simple random sample of 64 cars, so my n is going to be 64, and the standard deviation from the population is given to me at 5. Of 64 cars of this model is chosen and found to have a mean gas mileage. So we did a sample of 64 cars and we had a mean gas mileage. That's not a population mean, that's your statistic, X bar, and it was 27.5 miles per gallon. They want us to construct a confidence interval, construct and interpret a 95 or 98% confidence interval for the mean gas mileage of the model, of that car model. So a 98% confidence interval. All right, so we hold on to that. All right, so to be able to do this question, we are going to have to set up our conditions. So the conditions on a sample mean question really is the same as they've always been. 1, it's an SRS, and that's true because it's stated in the question. All right, 2, our n has to be large. All right, I read the question, it says nothing about being normal, so our n has to be greater than or equal to 30. And in this case, our n is equal to 64, so we're good. And we know it's now normal. Number 3, to be able to use the z-star score, our population standard deviation, this is the standard deviation from the parameter, has to be known. And that is. And we got that to be 5. Okay? So now what we're doing is we're ready to actually go ahead and we're actually ready to construct this confidence interval. So I want a 98% confidence interval. Now according to the formula, it's going to be your estimate. Your estimate is the statistic that you're dealing with from your sample, so that's 27.5, then plus or minus. The next piece is your critical value, is your Z-star critical value. Well, your Z-star critical value is coming from the bottom of table C, confidence level C. It says 98%. Since we know the standard deviation, we're not going to go inside the table. We're going to use that value, which is 2.326. 2.326. And then we're going to multiply that by the standard deviation of the estimate. Well, the standard deviation of the estimate is going to be the standard deviation that's given divided by the square root of n. That is going to be 5 divided by the square root of 64. This is going to be 5 divided by 8, which is equal to 0.625. Okay. And then that goes into the formula. So our 95% confidence interval will look like this. It's going to be 27.5 plus or minus. And then I have to multiply 2.326 times 0.625 equals, and I'm going to get plus or minus 1.45375. So there is my answer. I'm going to come down here. Now I'm going to actually create the confidence interval. You get the low point of the confidence interval by taking 27.5 and subtracting. So 27.5 minus 1.45375. And I'm going to get 26.04625, comma, and I'm going to get 27.5 plus 1.45375. And I'm up to 28.95375. So there's my confidence interval. All right, so that's the answer to the question. Now they want me to interpret the answer. So here we go. Interpretation. Oop, I'm off the page. I'll start here. We are 98% confident that the true mean of gas mileage for a certain model car is in the interval 26.04625, comma 28.95375. So we're 98% confident that the true mean gas mileage is between those two numbers. And notice the numbers aren't that far spread, and with this 98% confidence interval, if a company claimed that their gas mileage was 27, yeah, this confidence interval will definitely support that. If the company's claiming that their true gas mileage is like 32 miles to the gallon, and it's not in this confidence interval, we have enough evidence now to say that the company's claim of 32 miles per gallon, let's say, is wrong. Because we're 98% confident it should be between these two numbers. There's not a lot of chance for that to be outside this interval. So that's one way of actually disproving a company's claim if it doesn't fall between these two numbers. Okay, so that's currently what we are dealing with, is creating these types of confidence intervals and then writing the conclusion up for that. So get the notes down for this problem and try to pull the problem apart piece by piece with the explanation that I gave you. And notice that it is different than the sample mean questions we were doing based on probability. But but the conditions are basically the same, and the running of the formula, which is given, it's just knowing where to plug the things, and then knowing what the confidence interval truly represents in words, because that's what we have to begin to write out and then begin to understand. All right, good luck with that.